Good afternoon, children. So today we are solving some of the questions from page number 232 which have been asked. The questions are on maxima and minima. The question goes like this. I am dealing with one question, that is question number 4. Prove that the function f of x equals to e to the power x doesn't have a maximum or minimum value, right? Let us deal with this question. So let me solve this one. I am having f of x, this is the solution, it is equal to e to the power x. As you know, our first step is always finding the derivative. Let me find the derivative. F dash x, it is equal to e to the power x. Same thing. Now for critical point, that is Cp, we have f dash x equals to 0, that is e to the power x equals to 0. Now look at this one. E to the power x equals to 0 has no solution for x. Why? Because if I say x, then x will be equal to log 0 and log 0 is not defined. So no solution. No solution means no critical point. Therefore it has no critical point, right? No critical point. If it has no critical point, that means no turning point. No turning point. If I plot the graph of this e to the power x function, it will go like this. It goes like this. This is f of x equals to e to the power x. So here you see the function is monotonically increasing. So it will never have any minimum value or it will never have any maximum value. So that means no turning point, it is never turning. Therefore I can conclude it has no minimum and also no maximum value, right? So you can solve this type of questions in this way by finding the derivative, right? Let us see another question on this. Here this is our question number 5. The question is, I am talking about suppose bit second, right? It also have been asked by you. I have to find the absolute maximum and absolute minimum value. Find the absolute maximum and absolute minimum value. This function is f of x equals to sin x plus cos x, right? So now let us solve this one. Okay, so if I go on solving like this, then f of x is given to be sin x plus cos x. So I have f dash x, it is equal to cos x minus sin x. Now let us find the critical values, and here the interval is given to be in the question. I have missed something. This is 0 to pi, right? X belongs to 0 to pi. Okay, so now let us put it, proceed a bit further. Now for Cp, that is critical points, f dash x, it is equal to 0. That means I have cos x minus sin x equals to 0. So if I solve this one, I will have sin x equals to cos x, and ultimately it will give you tan x equals to 1, and tan x equals to 1, x can be pi by 4. I cannot write the value beyond pi, that is why only first quadrant value I have to take. This is only possible in first quadrant. Also in third quadrant it is possible, but I cannot take since my x is defined from 0 to pi, right? You see the x is defined from 0 to pi. Clear? So that is why I have taken this one. Now as I have suggested you, f dash x expression should be taken as the reference and you name it as equation 1, right? Now from that you find out f double dash x. Okay, so now from 1, f of x equals to, this is cos x minus sin x, therefore f double dash x, this is f dash x, so f double dash x, it will be minus sin x plus cos x, right? Now at x equals to pi by 4, what happens? Let us see. Look at this, f double dash x, it will be equal to minus sin pi by 4 plus this one will be cos pi by 4, right? Now let us proceed. Minus sin pi by 4, that means it is minus 1 by root 2, and this one is plus 1 by root 2. So 0. We know f double dash x equals to 0. If it is the case, then we do not have any point of that is called point of inflection. So therefore x is called the point of inflection, right? Now let us see, if it is the point of inflection, then what should be the maximum value? Let me tell you. Children, I have committed a mistake over here. This is actually यहाँ पे गलत हो गया है. Here you see, this should be minus. Look at this. This symbol, whatever we are using, it should be minus 1, right? Here it is minus, and here also it will be minus. If I change it, and here also the sign will be minus. Okay, if it is minus, then hence it will be look at this, I am just changing this. So it will be minus 1 by root 2, again minus 1 by root 2, which is minus 2 by root 2, and it is negative. If it is negative, therefore I can write, therefore f attains maximum at pi by 4, x equals to pi by 4, right? So now I have to make a table. Table में that you will write boundary values and CP, then f of x, which is equal to sin x plus cos x. From that I will analyze which one gives you the maximum value and which one gives you the minimum value. Now our boundary value starts from 0, because our x belongs to 0 to pi, right? Now after 0, then I have another critical point in between. The critical point is pi by 4 and the end point is pi. This 0 and pi, they are called the boundary values. So if I go on writing, this is f of 0, which is equal to sin 0 plus cos 0. This is 0 plus 1, 1. This is f of pi by 4, which is equal to sin pi by 4. This is 1 by root 2 plus 1 by root 2, which is equal to 2 by root 2. Hence it is root 2. Then f of pi, it is equal to sin pi, which is 0, and cos pi, which is minus 1. So now if I conclude this, then this one will be the absolute maximum and this one will be the absolute minimum, right? So absolute maximum value, it is equal to root 2, and absolute minimum value, it will be equal to -1. So this is how we solve this question. You can see the solution. आप शुरू से एक बार देख लेना इसको, and you complete the notes on it, right? First I have found fx, then we have found f dash x, then we have analyzed the result in this way. You also simply pause this video and keep on writing the notes. Clear? So that's all for today. These two questions I have kept it for today, and whatever doubts you have in the further questions, you can ask it. Okay, so that's all for today. Thank you very much.